Alright, so for this project, we're going to need to first of all define a few variables and understand why we name them certain ways. So, this is the lab handout that we will receive. So first of all, we're going to measure all the dimensions of the existing light fixture in centimeters. That's important. So we're going to just take those measurements and we're going to see what we have to measure actually. So this is what it should look like. This is a diagram of what it looks like inside the light fixture. So our goal is to replicate this part here and implement a more ellipsoidal shape. So yeah, and as you can see, the lamp here will be replaced by an LED, and you have to take that into account, of course. And yeah, so here's the shutter, and here are the lenses that that we will talk about later. Over here, we're going to set up the coordinates, and just keep in mind that it should be as large as the original light fixture. Alright, so here is the diagram. Now, L prime is going to be this distance, okay? So from your 0 to all the way to your focal point where your LED will be. And then your L will be your second focal point where your shutters are going to be. So those are some important measurements. You will also need to find what's your B, what's your A, like from the middle here and all the way here to here, that's your B. And yeah, this is just a random point that you will choose, the x0 and y0. These are a random point that you will need to choose. And alpha here is an angle that you will define as well in your Excel spreadsheet. So this equation should look familiar. It's what we've seen in class, and it's to describe this kind of ellipse. And it's in terms of L and L prime. And we will use that in our Excel. And in your Excel spreadsheet, you will simply increment your L prime this way, and you'll find your Y, and that'll be that. And yeah, for the straight line, yeah, exactly. You're gonna have your slope over here determined by K, and Y0 and X0 are the coordinates that we mentioned before. So this point here. So where you want the slope to start. And where is it? Yeah, so K, tan of alpha, and that's how you're able to plot a straight line in Excel like this. So these are the parameters that you will need to know in order to create your Excel spreadsheet to see what your ellipsoid would look like if you took a cross section of it. Yeah. And this is actually a graph that we produced using the formulas that you saw. So it starts off at this point there, and you can see the slope. And as you can see, it begins over here where the LED will be, and where these end, that's where the shutter is going to be. So your light goes here, bounces all around, and ends up towards the shutter. In this part of the lab, you will simply design your product on SolidWorks. You could make holes, make some modifications to it, but you just got to make sure that it's going to fit inside the light fixture, because as you saw in the diagram, you don't have much room here. So just take that into account. So how it's going to be evaluated, we're going to evaluate the Excel file, the SolidWorks file, and the product. So we're going to actually measure the lux, the amount of lux that we can measure on a whiteboard when we're using your device. So yeah, try to make it as performant as possible. And that is it. All right, hello. So today we have to do the ellipsoid lab. So this is how you do it. First of all, you got to know a few things about ellipses. So as you could see, imagine here is the focal point, right? The rays that you are emitting here will get reflected back to the other focal point, okay? So with this property in mind, we need to design an ellipsoid shape that will basically do this, but for a light fixture, okay? So over here will be the shutter, right? Where there will be another lens that will make all these rays here parallel. So your goal is to get most of these rays at this very point. So to do that, we simply put our light source here and simply, well, make the shape of an ellipse until a certain point so that most of the rays will end up right there at that focal point. So let's take a closer look at the Excel to do this. So you'll need to take a couple of measurements. So L is the distance between here and over here. So from your 0, okay, to the focal point. That's right there. And your L prime will be the other focal point. And then you have also to measure a few parameters like B and A. So the height and the width of your ellipsoid that you need to measure in order for it to actually fit in the physical light fixture. And your C will be calculated automatically. Now, you make a function like this to increment it, and you'll be able to see it here, right? That's what you're seeing. Okay, and you also have a minus, and these are these lines here. So as you can see, the ellipsoid will not continue infinitely. I will simply cut it off at that focal point because the angle at which, for example, if your light source starts here and hits over there, it's not going to go back to your lens. It's simply going to reflect back to like there, and bounce around. So you might as well just take a linear line to make it bounce at a very low angle towards the lens. So that's what the idea is. So once you have your measurements, you could finally go into SolidWorks and design it. So here you have my model, and let's look at the sketch. So you need to take into consideration the diameter of this hole here where your light will go in. So this is located at the focal point, okay? And over here, this is where the shutter will be. You will need to also take into account the diameter of the shutter, like it's not just a big hole. You need to make it reasonably sized. Next, you also need to. This is my A. So yeah. Oops. And here you have a little lip that will basically hold that will help hold the ellipsoid in place inside the light fixture. And this is my B. So these are my parameters. That's how you do it. You make an ellipse here, okay, that starts at 0. You offset the entities, right? And you make linear lines, define an angle, define some measurements like I did here, and then you will simply revolve the base. So yeah, revolve base, and you should get something that looks like this. So it's always equal and all around. So it looks like this. I put a slight fillet here that will basically help the structural integrity of that lip, because if it's all flimsy, it may break, and that you don't want that. All right, so that's pretty much it. So previously, I showed you how, like, what the light rays look like their pathing looks like, with the focal point being where the object is. But in real life, it doesn't really happen to be that precise. So let's look at, like, if we give our object here a certain offset. Now, as you can see, it's not meeting up towards the focal point perfectly like we saw with the previous one, but rather it's dispersing, and you see this one, like, it's not following where we want it to go. So that's also why we stop the ellipsoid shape and make it more linear. So we could decrease this angle and make it go towards the shutter. So as you can see, we're only taking into account a certain range of angles, but this also goes below here. So this is basically symmetric, and you could imagine these sets of rays being on the opposite side. So you got to bear that in mind as well, that nothing is perfect, and that's why we have to make a certain linear shape to it. All right, so here we have the light fixture that I was talking about. So you can see that's where the shutter is. So like you could adjust these, and there's a few of them right here and there. But for the sake of this experiment, we're going to put them all towards the outside. And down there, you can see there's a lens. So our goal was to make an ellipsoid that would direct all the light coming from the light source that I have right here. So this is it. This is the light source I was talking about. And we're going to put this on one end here. It's going to fit like that. And we're going to simply put this in there so that it will shoot the light out into the lens onto something that we're going to try to project onto. So that's the goal, and we're going to test them out.
Ready?
Alright, wow, first time we see this. 999? What?
Woo! Wait a minute. That's a pretty big lux number.
200. Thought something was burning.
Yeah, it's called my hand.
Oh, yeah. I mean, that's not as important.
Thanks, Zach.
206. I don't know, I can't see what we saw before. Anything above 202. Yeah, right here. Right here I get to 100.
Wasn't it somewhere down lower?
Yeah, that's what I thought, but I can't find it. Here's like 140, 156, 160.
Alright, I can't.
Alright, drop it.